Hello student, welcome back to lecture series on linear algebra. So guys, in my today's video I'm going to explain to you all normal form of matrix. Okay, so how the normal form of matrix it look like and how can we reduce given matrix into the normal form. Okay, so the major use of the normal form of matrix that mostly we used to find the rank of matrix, okay, using the normal form of matrix. Okay, so without further ado guys, let's get down into our today's lecture. I'm gonna explain to you all what actually the meaning of normal form of matrix, and then I'll explain to you all what are the steps needed that we can find normal form of matrix. Okay, and thereafter we go for the sum of example. So let's dive into our today's lecture. Okay, what is the normal form of matrix? Okay, so for that you need a matrix. So I consider matrix here as a m by n. Okay, so the normal form of a matrix we write is the identity matrix IR. Okay, you consider IR as identity matrix. Okay, IR as identity matrix. This one is the normal form. Okay, that means all diagonal element 1 and remaining element 0. Okay, yes, that one is the we define as the normal form of a square matrix. Okay, if the matrix it is not square, so in this case we write, okay, if the matrix is a not square, okay, if this matrix is a not square, like a 3 rows 4 columns, like something like this. Okay, so in this case we write IR comma 0. Okay, in actual this is not comma guys. Okay, this is not the comma, we do not use the comma between rows and columns. Okay, IR and 0, this one is the normal form of the matrix. Okay, so how it look like, let me tell you. Okay, IR means identity matrix of order R. Okay, and 0 matrix means this one is a 0. Okay, this one is the normal form of matrix. That means first we have 2 rows as an identity matrix and last one is a need to be a 0. Okay, that one is the normal form of the matrix. Okay, now let me define one more. Okay, IR, this one is the identity matrix and below here 0. Okay, so I just have given the example for 2 by 2 matrix. Okay, so you can take identity 3 by 3, 4 by 4, it can work also. Okay, yes, so IR and 0. So see that entire first 2 row it is identity matrix. Okay, 1 1 0 0. Okay, and at the end row we have only 0 row. Okay, so this form we define like this way. Okay, for the 2 by 2 identity matrix. So if you want 3 by 3, you can increase 1 0 here and again 3 rows above here. Okay, yes, that should be the normal form. Okay, this one is a normal form, this one is a normal form of matrix A, this one is a normal form of matrix A. Okay, yes, so again we have more normal forms. This one is the normal form. Okay, IR 0 0 0. Okay, okay, mostly we consider this one as a block matrix. Okay, block matrix means one of the block is identity here, another block is 0, another block 0, another block 0. Okay, so that one can be considered as the normal form. Okay, so this value should be present 1 0 0 1. Okay, this one is 0, this one is 0, this one is 0, this one is 0 0 0 0. Okay, so you can take this way, that can be work, or you can take it for 4 by 4 also. Okay, this one is the normal form. Okay, this one is one block. Okay, this one is one block, this one is one block, so consider this one for this one. Okay, so I hope you all have understood how the normal form of matrix look like. Okay, so all are the normal form. Okay, all are the normal form. So if you're confused what is IR, so you can write here IR as a identity matrix of order R. Identity matrix of order R. This is the identity matrix for order R guys. Okay, so that means this IR, this IR, this R and this one, all are the identity matrix of order R. So about the block matrix guys, I will explain with one of the separate lecture. Okay, how the block matrix look like, how the characteristics are there. Okay, yes, but for today's lecture you supposed to understand what is the actual meaning of a normal form of matrix. Okay, these all are the normal form for given matrix. Okay, yes, so we used to find a rank by normal form of matrix and we used to find the rank by row echelon form. So what is the actually difference between normal form and row echelon form? Okay, So I will explain that difference. First, write down some of the steps. Okay, how can we find the normal form of a matrix? Okay, steps to find the normal form. But for that we need to have some of the matrix. Like for example, matrix you consider. Okay, let me take one matrix. Okay, so consider matrix A. For example, matrix I'm taking here just to explain how can we find the normal form of matrix. Okay, yes. So make sure that matrix can be any order. Okay, like even odd order, that will be work. Okay. Okay, so let me take A, B, C, D. Okay, E, F, G, H, I, J, K, L. Okay, I consider these are the variable. Okay, you can take anyone, A1, A12, anything can work. Okay, yes. So I'm gonna explain here to you all how the normal form of matrix we can find. Okay, yes. Make sure that here we are going to operate row transformation and column transformation together. Okay, row and column transformation together. Okay, yes. So what we have first task. Okay, step first. Now observe this matrix only. Okay, so what is the order for this matrix? 3 rows, 4 column, 3 by 4. Okay, 3 rows, 4 column. Okay, I'm explaining step here. First step, A should be 1. Take A which is equal to 1. That means you have to reduce by row transformation or column transformation A as 1. Okay, yes. Then step second, apply row transformation. Applied row transformation and reduce E0 and I0. Okay, that means E and I need to be 0. First A1, E0, I0. Okay, this one is a step second. Okay, step third. So we go for the step third. So what step third needed? We want the B, C and D 0, but make sure that apply column transformation. Okay, apply column transformation. Apply column transformation and reduce B0, C0 and D0. Okay, so you have to apply column transformation for B, C and D2 in order to get them 0. Okay, this one is a step third. Step fourth, let me explain step fourth. Okay, we want F as 1. Take means you have to do some row transformation, column transformation, so that F can be 1. Okay, yes. Step 5, you have to repeat similar like a step second, and then left over step third and the step fourth and so on. Okay, yes. So what is the next step? So we got the F as 1. Okay, apply row transformation, make J0. Okay, row transformation and make J which is equal to 0. Okay, apply row transformation, make J 0. Again step 6. Okay, apply column transformation. Make G and H 0. G0, H 0. Okay, so we got the J0, G0 and H 0. Okay, yes. At the end make K0. At the end make K1. Okay, then K which is equal to 1 by row transformation, column transformation, and L is a 0 by row transformation or column transformation. Okay, these are the entire steps, guys, for finding the normal form of matrix. Okay, I hope you all have understood how the normal form it works. Okay, might be at the beginning it is quite confusing to understand, but once we complete some of the example, guys, you will come to understand how the easy part is. Okay, yes. Now our main question here, what is the difference between row echelon or canonical form and normal form? Okay, let me write that one. Echelon or canonical form. Echelon or canonical form and a normal form. So we learned these two methods now. Yes, echelon or canonical form and normal form. Okay, so what is the major difference between them? Okay, to find echelon form of a matrix we can use only row transformation. Okay, so we can use only row transformation. What we use here, we apply only row transformation for finding the rank or row echelon form of the matrix. Okay, yes, but for finding the normal form of a matrix we use row plus transformation. We use row transformation plus column transformation. Okay, see that these are the major difference between echelon or canonical form and normal form. Okay, I hope you all have understood what is the difference between them. Okay, and plus the normal form of a matrix. Okay, how the normal form of a matrix it works and how it look like. Okay, this is the entire definition for normal form of matrix and the steps I have added here. Okay, for finding the normal form of matrix here. Okay, you all can refer these steps. About the example, guys, in our next lecture I'm gonna explain to you all some of the example based on the normal form of matrix. Okay, I hope you all have understood everything here in my today's lecture, guys. So that's it for my today's lecture. If you found anything difficult or anything confusing, let me know in my comment section, guys. I'll come up with the similar videos. So thank you everyone. That's it for today's lecture.